let's apply all four formulas to an example and compare their results, no? Say, for example, we want to find the area under the function 1 plus e raised to negative x sine 4x from 0 to 1, no? This is not trivial to integrate analytically, so it would be perfect for testing our quadrature formulas. First, we apply the trapezoidal rule, no? If we recall the formula, h over 2 times f of a plus f of b, no? We have h as the distance, no, of a to b. So that would just be 1 minus 0. That, and a is at 0, so it's 0. The function value at a, no, we just substitute 0 here, so that's 1 plus e raised to um negative 0 sine 0, no, sine 0 is 0, so multiplied to e raised to x, that would just be 1, no? Then we evaluate at b. At b, we just plug in the we just plug in 1 to the function, no? So that's f of 1 equals 1 plus e raised to negative 1 sine 4, no? Remember to use radians when using your calculator, since we are working with um, trigonometric functions, no? This would result in 0.721588, no? And if we substitute these values, we now have all the needed for the formula, no? We have h, we have f of a, we also have f of b. We just plug in these values to the formula, so that's h is 1, so 1 over 2 times f of a is 1 plus f of b, that's 0.721588, and that would lead us to the approximated area under the curve being 0.860794 units, no? Denoted by the green area, no? Here, the blue area is the error. Now let's move on to using naman Simpson's one-third rule, no? If we recall, this is the formula h over 3 times the summation of f of a and f of c plus 4 times f of b, no? In this case, we have 3 nodes, no? And h is the distance between nodes. So that would be 1 minus 0. So that's the end node. This is c minus the other end node. So that's a divided by how n minus 1. So we're using 3 nodes minus 1. That's 2. No? We're subdividing it into 2 equal parts. Yan lang. That would be 0.5, no? So we have h. Now we can get also a, b, and c. So a is 0, no? Since a is 0, we can evaluate f of x, no? F of a, I mean, just plug in 0 here, so that's 1 plus e raised to negative 0 sine 0, no? F of a would just become 1, no? Since sine 0 is 0 times 1, that's 0 still. Then we get the function value at b, no? So since b is in between a and c, no? That's just the average of a and c. no? We plug in b to the function, no? No? That's just 1 plus e raised to negative 0.5 sine 2, no? And that would lead us to a value of 1.551517. For c, it's just the same, no? It's a b from previous, so we could just um copy from the previous, no? Evaluated at 1, the function becomes 0.721588, no? Now we have all, no, those needed for the formula. We can now compute. The area under the curve is approximately 0.5 over 3 times the sum of 1 plus 4 times 1.551517 plus 0.721588. No, we're just substituting those values we got, no, to the formula. This would lead us to an answer of 1.321276 units squared, no? The area is the green area here, no? Notice that lumiit na yung error, no? Or yung hindi na approximate na area. Now, we use Simpson's 3/8 rule, no? If we recall, it has a formula of 3h over 8 times f of a plus f of b plus 3 times f of b and f of c, no? We are using 4 nodes this time, so that's b minus a over n minus 1, no? N minus 1. We're using 4 nodes, so that's just 4 minus 1, so that's 3. No? H now becomes 1/3, and the nodes are, no, a being 0, b being 1/3 or 0.33, c being 0.66, and d being 1, no? We just add h from the initial node, no? So if we add a plus h, that's b, a plus 2h, that's c, a plus 3h, that's d, no? We evaluate the function values at a, b, and c. At a, it becomes 1, no, from the previous. And at d, that's also from the previous, no.